Hi there. Let's do a couple examples of circuit analysis. This one that we're looking at right now is number 16 in the homework. This is a compound circuit, meaning that we do not have, it's not simply series or simply parallel, it's a combination of both. And so the analysis is going to be slightly more complex. When I say analysis, the first thing we want to do is find out the number of currents, and then we are going to determine the value of those currents and the voltage drop across each resistor. The first step usually the best thing to start with is finding the total resistance of the circuit, because that's always going to allow us to find the current through the battery. So let's start off and do that. We've got two here in series, a 6 and a 3, which is the equivalent of a 9. The 9 that these would make up is in parallel with this 3, so our total resistance here will be equal to 1 over 3 plus 1 over 9. And let's see, what does that come out to? And if we take the inverse of that to get the total equivalent resistance, we get 2.25 ohms. Okay, why is that important? Because that can allow us to find the current through the battery. If we use Ohm's law, we can find the current through the battery by taking the voltage of the battery and dividing it by the total equivalent resistance. The voltage is 10, and this total equivalent resistance is 2.25 ohms. Okay, what we get there then is a current of 4.44 amperes. Okay, I'm just going to draw this in over here. I've got 4.44 amps of current going through the battery. Okay, and we know that that current starts all the way from this node, travels through the battery, and goes all the way up to this node. That will be useful to us at some point. I told you guys that it would be a good thing to organize your information by making a little chart. Something like that. Let's see, I've got a 3 ohm resistor on the bottom, and then a 6 ohm resistor on top, and a 3 ohm resistor on top. Now that current that I found is not the current through any of those resistors, but like I said, it will be becoming useful to us eventually. Not being able to find any resistances, I want to start thinking about voltages. Okay, if I pretend I'm a charge and I come out of the 10 volt battery, I'm a charge that has 10 volts to deliver to my resistors. If I go around through this first branch, I pass through the 3 ohm resistor and come back to the battery. I've only gone through one resistor. That means that that 3 ohm resistor is going to get all 10 volts I have to offer as a charge that carries these volts. Now, of course, that's a little analogy, but it works for us. Having that information, 10 volts and 3 ohms, I can find the current. 10 volts divided by 3 ohms, which is solving Ohm's law for the current, gives me 3.33 amperes. Okay, so now I know this current going through here is 3.33 amperes. I also like to write things like what the voltage is over here. I keep track of the information in 2 different places. It just sometimes helps me. You don't have to, but it works for me. Seeing that, again, I don't know what the voltage is up here. I know that if I'm a charge and I come out here with 10 volts, I'm going to use some going through the 6 and some through the 3, but I don't know how much. So what I'm going to do is think about currents now. I have 4.44 amperes of current coming up from the battery and going into this node. From there, I have 3.33 going through the 3 ohm resistor here, which means that the rest of it had to go this way. Okay, if I take 4.44 and divide 3 and subtract 3.33, I get 1.11 amperes of current. And this current will come up through both of these resistors and down to this node over here. That means both of these resistors have a current of 1.11 amps. They share the same current because they're on the same branch. and that's always true. Now, having this information, I can solve for the voltages. 6 times 1.11 is 6.66 volts, and 3 times 1.11 is 3.33 volts. So now my charge leaves the battery with 10 volts, uses 6.66 here, 3.33 there, and if you add those together, you come right out to, with a little bit of rounding, 10 volts, and it checks out. Now, I said this 4.44 was going to come in handy, and it did. It allowed us to find the current through the resistors on top, and now we've completely analyzed this circuit. Now, for example, problem number 18. This one is also a compound circuit. This time we have a resistor on the same branch as the battery. So we're going to have to analyze it slightly differently. But once we get the principles down, we can analyze any circuit. First thing, of course, we want to find is the total equivalent resistance of the entire circuit. So these, again, you cannot add these. These are not in series. You can't cross a node. But these two up here are in parallel. One secret for recognizing that they're in parallel is that they both are connected to the same nodes, this node and this node, and neither of them have a battery on them. So that means they're in parallel. And that means that I can add them using the parallel rule of 1 over the total resistance equals 1 over each of their values. And we did a very similar one for the last one, so we can kind of skip right to the answer without showing all the steps of 2.25. The equivalent circuit for this would be replacing the 9 and the 3 that are in parallel with a 2.25 right here, and this would become a simple series circuit with a 5 and a 2.25 in it. If we add those two resistances, we get the total resistance being 5 plus 2.25, which now equals 7.25 ohms. That is the total resistance for the entire circuit. What can we do with that? Find the current through the battery. I'm going to just take this and abbreviate it with a B for brevity's sake. And the current through the battery equals the voltage of the battery over the total resistance. And we have the voltage of the battery at 10 volts and the total resistance at 7.25 ohms, which gives us a current of 1.38 amperes. Now, this becomes immediately useful. This current starts here, comes all the way down, passes through the battery, comes all the way up, passes through the 5 ohm resistor, and comes to this node. That means that the 1.38 amps also goes through the 5 ohm battery, and I can write that here. This is nice because this is going to allow me to solve for the voltage being dropped across the 5 ohm resistor. If I multiply these two values together using Ohm's law, I get 6.9 volts. Now let's do a little bit of detective work. Okay, I have no clue how this current is going to split up when it goes through these two resistors, but one thing I do know is that I am dropping 6.9 volts when I go through this one. Okay, so a charge comes out of here with 10 volts. Loses 6.9 here, and loses the rest here, okay, because it's only passing through this one more resistor. If it goes up this way, it's going to lose that same amount up here. If I take 10 and subtract 6.9, I get, I'm going to write it over here, 3.1 volts. And that's the same for both of them because they both are you're either going to go through one or the other, but you're going to have already lost that 6.9 volts before you get there. And the other thing is that any resistors that are in parallel always have the same voltage. Now I can calculate the currents. And if I do that, I'm going to get that the current here is 1.03 amps. And remember, I'm getting that by taking the voltage and dividing it by the resistance, just like Ohm's law says. And then down here, I'm going to get 0.34 amps. Let's see if we can check this against reality over here. The current going through here is 1.38 amps. It's going to split into two different paths, and that would mean that this current that it splits into and this current that it splits into have to add up to this current, and they do. Of course, rounding makes it so they don't look like they do, but they really do. And we've now completely analyzed this circuit. Okay, so the key here that I hope you take away from this is if you have a resistor or two or three or however many you have that are on the same branch as the battery, they share the same current as the battery, and you get this added advantage that once you find that current through the battery, you've also found the current through one of the resistors. Hopefully you guys will take this information and use it on your other practice problems and hopefully get 19 and 20, which are a little challenging, but I know you guys can do it. Good luck with those, and good night.